Hi, welcome to the Mathematics MI channel. In this video, we are going to solve this interesting integral. Integral from 0 to pi over 2 cube root of tan of x times natural log of tan of x. Okay, how to begin? Well, as a first step, I'm going to define the integral. I'm going to take integral from 0 to pi over 2 tan raised to the p power of x dx. Then we can convert tan into sine and cos. So integral from 0 to pi over 2 tan of x, we know sine raised to the p of x over cosine raised to the p of x dx. Then we can rewrite this integral from 0 to pi over 2 sine raised to the p of x times cosine raised to the minus p of x dx. Okay, then we can use the definition of beta function. So we know beta of beta of mn is equal to 2 times integral from 0 to pi over 2 sine raised to the 2m minus 1 of x times cosine raised to the 2n minus 1 of x dx. We discussed about we prove this beta function identity in a previous video. I will add the link in the description. So now we can write our integral is equal to 2 times beta of not 2 here, 2 this side, so 1 half, so 1 half times beta of here we have the power 2m minus 1, so we know 2m minus 1 is equal to p, so m is equal to 1 plus p over 2, and 2n minus 1 is equal to minus p, so n is equal to 1 minus p over 2. So we can write here beta of 1 plus p comma 1 minus p over 2. Okay, then here beta function. Now we know the relation between gamma function and beta function. Beta of xy is equal to gamma of x gamma of y over gamma of x plus y. So now we can write here 1 half gamma of 1 plus p over 2 times gamma of 1 minus p over 2 over gamma of x plus y. We know if we take sum of this part, gamma of 2, so gamma of 1 we know 1, so the denominator will be 1. Okay, then now we have gamma of 1 plus p over 2 times gamma of 1 minus p over 2. Now I am going to recall the Euler's reflection formula. We know gamma of n times gamma of 1 minus n is equal to pi over sine of pi n. Now also we know gamma of n plus 1 is equal to n times gamma of n. So here now instead of gamma of n, I am going to use gamma of n plus 1 over n. So we can write gamma of n plus 1, here gamma of 1 minus n, and here we have gamma of n plus 1 over n. So I'm going to multiply by n, so here pi n over sine of pi n. Okay, then I'm going to take if we take instead of n plus 1 over 2, if we apply instead of n plus 1 over 2, so we have here gamma of here 1, so 1 plus instead of n, now we have n plus 1 over 2 times gamma of 1 minus n plus 1 over 2 is equal to pi times n plus 1 over 2 over sine of pi times n plus 1 over 2. Okay, then to simplify, again we can use this formula. We know gamma of 1 plus n is equal to n times gamma of n. So here also we have gamma of 1 plus, instead of n we can use n plus 1 over 2. So we can apply this formula. So we have n plus 1 over 2 times gamma of n plus 1 over 2 times gamma of, here if we simplify this part, we know 2 minus 1 minus n over 2. So gamma of, gamma of 1 minus n over 2 is equal to pi times n plus 1 over 2 over, here we have sine of pi n plus 1 over 2. So if we simplify, it's, we know for sine of 5 over 2 plus 5 n over 2. So cosine of pi n over 2. Okay, then we know this n plus 1 over 2 get cancelled. Now here our integral gamma of 1 plus p over 2, gamma of 1 minus p over 2. So we have this part. So we can write this is equal to 1 half pi over cosine of pi n over 2 instead of n. Now here we have p, so pi p over 2. Okay, then now we know our integral from 0 to pi over 2 tan raised to the p power of x dx is equal to, now here we have pi over 2 secant of pi p over 2. Well, now this is the point. Now if we differentiate with respect to p, we know tan raised to the p of x times natural log of tan of x. So now I am going to differentiate. So we know 0 to pi over 2. Now here we have tan raised to the phi of x times natural log of tan of x dx is equal to, now if we differentiate this side, we know the derivative of secant times tan, tangent, and we should multiply by the coefficient of p. So pi over 2, here also pi over 2, so 5 square over 4 secant of 5p over 2 times tangent of pi p over 2. Okay, then now in the question we have cube root of tan of x. Therefore now I'm going to take, now instead of p I'm going to apply p over k. Instead of p, now I'm going to apply p over k. So now we can write integral from 0 to pi over 2. Now instead of p over k, so we know kth root of, here k, tan to the p of x times natural log of tan of x dx is equal to, now here we have 5 square over 4 secant of pi p over 2 times k times tangent of pi p over 2 times k. Okay, then as a next step, final step, now I am going to plug in p is equal 1 and k is equal 3. When p is equal 1 and k is equal 3, we know our integral from 0 to pi over 2, k we know 3, so cube root of tan of x times natural log of tan of x is equal to, here 5 square over 4 times, now here we know pi over 6, we know secant of pi over 6 is equal to 2 over square root of 3 times here tan of pi over 6, we know 1 over square root of 3. So if we simplify, here 2 get cancelled, here 3 times 2 6, so 5 square over 6. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.